Boleh, Miss.
Boleh,
Can
Miss.
miss.
Can, Miss.
Boleh, Miss.
Okay. Okay, kita start ah. So based on the poll, we will only be discussing 4 questions. And then the first question is from exercise 1, which is number 3 lah. Okay. Boleh start sudah? Semua ready?
Boleh, Miss.
Ready, Miss.
Okay. So if you have any problem during the session, kasih tahu Miss ah. Macam tidak nampak the screen ka. Okay. Right, so question number 3. Okay, so the first question. Okay, this one. So the radius of the Mercury's circular orbit around the Sun is 5.79 times 10 to the power of 7 kilometer. Okay, so this Mercury travels around this orbit in 88 days. Okay, so before we start, we have to always extract the information available lah. Okay, so the first information that we have from this question is the radius. So I'm going to write it down here. So question 3, the radius is 5.79 times 10 to the power of 7 kilometer. Okay, and then it also gave us the period, which is T, equal to 88 days. Okay, so the question are asking us to find the linear speed of the Mercury and then the radial acceleration of the Mercury. Shirley, can you tell me the formula for linear speed?
Linear speed is V equal to 2 pi R over T.
2 pi R over T, ataupun ada satu lagi formula dia. Before kita extract omega tu. Omega. The
2
angular velocity.
2 pi R
2 pi R.
Yes, Vincent?
V equal to R omega.
Yes, thank you, Arzarul Rizal. So the equation is V equal to R omega. Okay, so from omega, baru kita dapat 2 pi over T. Okay, so the period, we have to use SI unit, which is in seconds lah. So 88, we have to times 24 hours per day. Lepas tu 1 hour is 60 minutes times dengan 60 seconds. So kita dapat 7.6 times 10 to the power of 6 seconds. Okay. Dari sini baru kita boleh substitute sebab this is now in seconds. Okay. So V equal to R, which is 5.79 times 10 to the power of 7 times 10 to the power of 3 sebagai kilometer. Then darab lagi dengan T, which is 7.6 times 10 to the power of 6 over sini 2 pi. So you should get the linear speed to be equal to 47.9 times 10 to the power of 3 meter per second. Okay, so yang ini ada problem. Miss tengok kamu punya solution, you don't really have any problem on this one because this one is quite direct lah. Ada yang ada problem?
No, Miss. No, Miss.
No, miss.
No, Miss.
Alright.
No, Miss.
No, miss.
Okay. Boleh continue ah. So question B pula, it asks us to find the radial acceleration. Okay, so radial acceleration can be calculated using the formula R omega square. Okay, so R is 5.79 times 10 to the power 7 kilometer darab dengan the angular, which is 7.6 10 to the power 6 2 pi. Okay, jangan lupa square. Okay, from here, just plug into the calculator, then you should get 39.57 times 10 to the power of, cannot really say, negative 3 meter per second square. Okay, so boleh question 3. This one is just
Boleh.
basically applying the formula from our notes. Okay, I'm gonna continue to exercise 2. Boleh? Kalau dia sempat, screenshot sekarang.
Boleh, Miss.
Okay, so
Boleh, Miss.
exercise
Boleh.
2. Kejap. Where is exercise 2? So exercise 2, kita akan discuss all 3 lah. Okay, so the first question is, a ball of mass 0.35 kilogram is attached to the end of a horizontal cord. Okay, so sekarang dia punya motion is horizontal. And then it is rotated in a circle of radius 1 meter. Okay, so radius there 1 meter. So if the cord will break when the tension exceeds 60 Newton, dia suruh kita determine the maximum speed of the ball and then the minimum period of the ball. Okay, so for this one, don't get confused. You just actually have to use the formula. But before we use the formula, we have to extract the information lah. Okay, so the first information we have is the mass, which is equal to 0.35 kilogram. And then we also have the radius, which is equal to 1 meter. And then the maximum tension is 60 Newton. Okay, so if we were to draw a diagram to see the situation, it will be somehow like this lah. So this is the, oops. So this is the horizontal circle. Okay, the motion of the ball. And then this is the ball. Okay. So it is moving in a horizontal circle. Okay. Right, and then we have the radius. Okay, so the radius is equal to 1 meter lah. Okay, so before we start, we have to draw the free body diagram lah. What is being experienced by this ball. Okay, so let's draw the axis. And then we're going to draw the forces. So it has mass, so it always has weight lah. And then we have the tension at an angle. Okay, so from here, this is the theta. Okay, so theta, this is the weight mg, and then this is the tension. Okay, boleh nampak ka? Alright. So now we can then find the maximum speed of the ball. Okay, so how do we find the maximum speed of the ball? Is by using the maximum tension lah. Okay, so F centripetal force, let me use red. So the centripetal force will be equal to mass AC. Okay, so the only centripetal force is the tension. Okay, so the tension is the maximum tension lah. Okay, which is equal to mv square over r. Okay, so the tension here is actually given. So instead of finding the value, we can directly use this maximum tension lah. Okay, so just substitute into this equation here. So 60 equal to 0.35 v square over the radius, which is 1 meter. And then we should get the maximum speed of the ball to be equal to 13.1 meter per second. Okay? Am I going too fast? Okay saja?
Okay, Miss.
Okay, Miss.
Yes.
Okay, Miss.
Okay. Right. Lepas tu, we are gonna find the minimum period
Miss,
pula. Yes?
Miss, I have a question. For T max kan, isn't it we supposed to take T max at the x-axis?
The one yang given here is already been resolved. So instead of finding the angle, we can just directly use 60 Newton. Just by using the maximum. Yeah. Okay. Can we continue?
Okay, thank you.
All right. Okay, so for question B, we are looking for the minimum period of the ball. Okay, so period, we can use VR and then 2 pi over T V. Okay, so rearrange this to get T equal to pi R over V. Okay, boleh? So dari sini just substitute 2 pi 1 V is equal to 13.1. So then you'll get the minimum period to be equal to 0.48 seconds. Okay? Boleh untuk question number 1?
Boleh, Miss. Boleh, Miss.
Okay.
Boleh, Miss.
Okay. Alright, now we can go on to question number 2, which is equal to, sorry. So the question 2 is asking us to calculate the angle theta where the mass would start sliding. Okay, so dia bagi kita this diagram. So this is a sphere and then the mass is placed here. So dia suruh kita cari angle theta ni when this mass would start sliding. Dia akan jatuh macam ni lah. Okay, so the only information that we have is the coefficient of static friction. Okay. So let me just draw this. Have the circle. And then this is the mass. Okay. Never mind, just gonna draw. So we have something like this. So this is theta. Okay, so in order for us to do this, we have to draw the free body diagram lah. Okay, so the free body diagram is at this point here. Okay, so we are gonna focus on the mass. Okay, the block. Okay, so I'm just gonna drag this here. So let's draw. So the mass the weight will be pointing down. Okay, so now dia tidak cakap dia frictionless. So we are gonna have a friction force opposing the motion. Okay, lepas tu it is in contact here, so there is a normal force. Okay, so normal force. And then other than that, do we have any other forces?
No, miss. No, miss.
Okay. So the angle theta is gonna be here. So this is theta. Mg, and then this is the static friction. Okay. So for this one, I'm gonna try to draw the direction of mg cos theta and then mg sine theta. Okay, so that you can further understand what I'm trying to do. So if we resolve the weight in the y direction, this one is in x direction. Okay, so if we try to resolve this is mg cos theta, and then this one is mg sine theta. Okay, so from here, the mass will only move if, okay, the mass will only move if mg sine theta is greater or equal than the static friction. Okay? So static friction ni the ability untuk dia stay static. Okay? So if yang weight mg sine theta ni greater than the static friction, it will cause the object to move lah. Okay? So dari sini we can continue mg sine theta mu s n. Okay, so where do we get that n? We are going to use the y component. Okay, so n minus mg cos theta equal to 0. So n equal to mg cos theta lah. Okay, so we substitute n into this equation here. So mg sine theta is greater or equal mu s mg cos theta. Okay, so our goal here is trying to find the angle. Okay, this theta. Okay, what is the value yang would cause the mass to move? Okay, so m di sini boleh kena cancel. So we are left, oh I forgot the g, sorry. mg can be cancelled. So we are left with sine theta greater or equal mu s cos theta. Okay, so rearrange this, we get sine theta over cos theta greater or equal to the coefficient of static friction. Okay, sine over cos is tangent. So tangent theta equal to mu s. Okay, so the angle is shift tangent mu s, which is equal to 6 di sini. So d theta is gonna be equal to 31 degree. Okay? Boleh?
Boleh, miss.
Boleh ah? Simple kan yang ini? It just asks you to find the minimum angle, I think. The angle, yeah. Okay? Boleh?
Boleh, Miss.
Boleh, Miss.
Boleh, Miss.
Boleh,
Alright.
Miss.
Boleh, Miss.
Okay, final question nih. After this 10 minutes, I think we're just gonna take another 10 minutes, and then you can continue with lecture on chapter 7 lah. Okay, I've uploaded it, and I think it's in your Google Classroom. Aduh. Okay, number 3. Okay, so a ball of mass 1.34 kilogram is connected by means of two massless string. Okay, so the string we can neglect dia punya mass. Okay, so it is connected to a vertical rotating rod. So this rod here is moving. The strings are tight and are taut, and then the tension in the upper string is 35 Newton. Okay, so the tension here is given, which is equal to 35 Newton. Sketch a free body diagram for the ball, and then calculate the magnitude of the tension in the lower string, the net force on the ball, and then the speed of the ball. Okay, so let's draw the diagram. I'm just gonna draw the no, I still need to draw the diagram. Never mind. Okay, so this is the rotating rod, and then we have the ball. Okay, and then this is the rope. Okay, this is 1.7 meter, and then the string length is given, which is equal to 1.7 as well. Okay, just gonna divide this into 2. Okay, so there's an angle here. This is theta. This is 1.7 meter. Sorry. This is 1.7 meter as well. Okay, so what we have to firstly do is we have to find the angle theta lah. Okay, so how do we find that is by using trigonometry. Okay, so this is, I'm gonna label this as L1. Okay, so L1, and then this is the radius, and then the string length, I'm gonna label it as L saja. Okay, boleh ya? So the information we have is the mass of the ball, 1.34 kilogram, and then the tension in the upper string, which is equal to 35 Newton, and then the value of L1 is just 1.7 divided by 2. So we are gonna have L1 to be equal to 0.85 meter. Okay, so now we can then find the angle theta by using sine theta. So sine theta is opposite divided by hypotenuse. So opposite over hypotenuse. Okay, so L1 over L. Right? So this is theta equal to shift sine 0.85 divided by 1.7. Okay, dari sini dapat angle dia equal to 30 degree. Okay, and then we have to find the value of R, which is the radius So r square equal to L square minus L1 square. Okay, so r is equal to the square root of 1.7 square minus 0.85 square. Okay, so you then get the radius to be equal to 1.47 meter. Okay, so that is the information that we need to solve this question. Now we can draw the free body diagram. Okay, so the free body diagram, I'm just going to take this. Okay, so we have weight, and then tension in the lower string, and then tension in the upper string. Okay, so the theta is equal, okay, so this is theta mg. The lower string, I'll label it as T2, upper string is T1. Okay, so now we can then find, what was the first question? The magnitude of the tension in the lower string. Okay, so we have to find the value of T2. This is A, B, 1. Okay, so for this one, we can just directly use chapter 4 punya solutions, which is we are going to look at the vertical component. So total force at Y equal to 0. So T1 sine theta minus T2 sine theta minus mg equal to 0. Okay, so T2 sine theta, rearrange T1 sine theta minus mg. Okay, so T2 is just T1 sine theta minus mg over dengan sine theta. Okay, so substitute all the values, which is 35 sine 30 degree minus 1.34, 9.81 divide by sine 30 degree. Okay, so you'll then get the tension in the lower string to be equal to 8.71 Newton. Okay, so if a solution is much simpler by using other chapter, kamu guna other chapter. Okay, unless they mention specifically, contohnya kalau kita perlu guna work kinetic energy theorem, then you cannot use other chapters punya solution lah. But then if it didn't mention, then you can directly use other chapters punya solution lah. Just make sure dapat betul lah jawapan. Okay, and then the second question is finding the net force on the ball. Okay, so the net force, we know it is the one, the axis yang ada motion. Okay, in this case, it is only on the x-axis ataupun the one that is going towards the center of the circle. Okay, macam ni. Semua ni towards the center of the circle. Okay, so net force is T1 cos theta plus T2 cos theta. Okay, so this is equal to 35 cos 30 degree plus 8.71 cos 30 degree, which then gives you the net force to be equal to 37.9 Newton. Okay? And then final question, it asks us to find the speed of the ball. Okay, so the speed of the ball kita boleh guna di centripetal force punya equation, which is MAC. Okay, so this is just the net force equal to mv square over r. Okay, so rearrange this. You should get the equation to find the velocity to be equal to net force times r over m. Okay, square root there. Okay, so then you'll get v equal to 37.9, 1.47 divided by 1.34. Okay, so then you get the speed to be equal to 6.45 meter per second. Okay, do you have any problem in this question?
No, miss.
Okay, semua okay. I think most of you have
Okay, miss.
problem answering question 2 based on your solutions DGC lah. But this one is quite simple. This type of questions, this one is usually the one that comes up quite frequently in exam lah. Okay, right. So we have another 30 minutes to spare in which you have to start watching the chapter 7 punya videos lah, which is on gravitation. Okay, so I've uploaded everything in GC. You shouldn't have any problem. But if you do, don't just not WhatsApp, message me in Telegram lah. Okay. So ada apa-apa soalan before we end today's session? Oh, before that, we will be having quiz discussion. It's today. Later at 2:30. Boleh kah 2:30?
Boleh, miss. Boleh.
Boleh,
Boleh,
miss.
miss.
Boleh, miss.
So 2:30 we will be discussing quiz pula. Yeah, 2:30 until 3:30. Yeah.
Okay, miss.
Okay. So ada soalan? If not, we end the session today. I mean, for this 1 hour, kita boleh end the session sudah lah. Dadah. Ada tips mau minta masuk KML?
Ya, tips, miss. Mau balik sudah nih.
Balik sudah nih. Bersedialah air.
Miss, semua terus kah balik nanti 11 Oktober?
I think you will come here. Ikut date. Different people have different region have different date, I think. I'm not sure. Kami pun belum kena bagi anything.
Kill, kau masuk awal, Kill.
Janja.
So like 11 October, all of us has to be
Kau masuk awal,
Yeah.
bos. 2 bulan.
Boleh sudah kita off? Boleh kalau ada
Boleh,
soalan,
miss.
let's...
Nggak boleh off, miss. Nggak boleh, miss. Nggak
Dah boleh kah?
Oi, masih mau buat gravitation. Let's
Miss,
go.
Nggak boleh, gila.
Don't
Soalan,
forget
miss.
C
Ada
and
soalan,
symbols.
miss.
Okay, apa soalan?
So, assignment tu bila, miss? I mean, assignment for physics.
Assignment lama lagi.
lama
Upcoming one
lagi.
is the one yang kamu perlu fokus for now is the practical skill.
Oh, practice skill, I see.
Miss bagi tu Jumat ni Miss bagi briefing. Yang itu kamu perlu buat video.
Oh,
Video?
okay.
Video.
Akil suka buat video, miss.
Oi,
Semua
Miss,
kamu
oh?
ni suka buat video.
Rajin kan, Kill?
saya vlog, miss. Vlogger.
Class representative semua ada kah kelas kamu? Actually Miss ada aja attendance, tapi mana tahu kamu tahu reason dorang tidak datang. Okay.
Kill.
Okay,
Ready
cukup
sudah,
lah.
Kill. Balik ke ML.
Mau belajar susah kamu nih chapter
Ready
7.
ka? Nasabar mo jumpa ko, boy.
Veron, makan kamera Veron.
Nggak mau lah masuk ML
everyone.
nih.
Bye.
Thank you, Miss. Bye.
Thank
you, Miss.
Thank you, Miss.
Telegram.
Thank you, Miss.
Kameramu.
Makan kamera.
Bye.
Take care, Miss.
Kameramu, Cruz, kameramu.
Cruz.
Veron.
Slow internet, narawat.
Representative, tolong buka kamera.
Kameramu, Cruz.
Veron.
Okay. Ada lecturer lain ni, oi.
Okay.
Miss.
Okay.
Kameramu,
Bye-bye.
Cruz.
Cruz, aku mau tengok muka kau sekali je, Cruz. Craving
Ya, Cruz,
nih,
cepatlah, Cruz. Rindu saya nih, gila.
Betul lah si Cruz.
Malu-malu gila si Cruz. Aduh.
Gila. Sudah, aku
Oke,
mau tengok
lagi.
video lagi nih, Boy. Sudahlah.
Bye.
Kau macam menipu, Tekil.
Yeah, bye,
Oke, bye, Miss.
Bye.
Bye.